Television is one of the greatest inventions of the 20th century, a device that forever changed how people connect, learn, and entertain themselves. Think about it. Before television, people relied mostly on newspapers and radios. Then suddenly, moving pictures with sound appeared in living rooms across the world, captivating entire families. Even today, television continues to evolve, surprising us with new technology and transforming how stories are told. But have you ever wondered how these televisions, the very screens that bring the world into our homes, are actually made inside factories? That's exactly what we're about to uncover. The story of television begins in the early 20th century. Inventors like Philo Farnsworth and Vladimir Zworykin pioneered the technology, making what once seemed impossible, possible. In 1939, the New York World's Fair introduced television to the public, sparking excitement for its commercial potential. After World War II, TV quickly became a household staple, with NBC, CBS, and ABC shaping American culture through groundbreaking shows and live broadcasts. The 1950s introduced color television, marking another leap forward. By the 1970s and 80s, cable networks like HBO and CNN expanded viewing options, while inventions like the remote control and VCR gave people more freedom in how they watched. Then came the 21st century digital revolution. Streaming platforms like Netflix and Hulu disrupted traditional cable, proving that television was not just surviving, it was evolving faster than ever. But behind every sleek, high-definition TV we use today lies an intricate process of design, engineering, and precision manufacturing. It all begins with research. Companies study customer needs. Do people want bigger screens, sharper resolution, smarter features? Based on this, designers sketch ideas and create digital models. Engineers then select the display type and resolution that match market demand. While the design team ensures the remote and user interface remains simple and intuitive, engineers build prototypes to test whether everything works together seamlessly. Here's a fascinating fact. The very first TV commercial in the US aired on July 1, 1941. It was a simple 20-second spot for Bulova watches. The cost? Only $9. Adjusted for today, that's about $180, a small price to launch an industry worth billions. After design approval, engineers focus on creating the TV's internal components. Circuit boards are carefully designed to manage power and support ports like HDMI and USB. At the same time, software developers build the TV's operating system, ensuring apps and smart features run smoothly. Mechanical engineers then design the outer casing, which not only protects the delicate parts but also manages heat during use. Once complete, prototypes are assembled and tested, pushing the design one step closer to mass production. Now comes the part where individual components are made. Display panels, often produced in specialized factories, are among the most crucial and expensive parts. Circuit boards, electronic chips, outer casings, speakers, and even tiny sensors are manufactured separately. Each piece undergoes strict quality testing before moving to the assembly line. On the assembly line, everything comes together like clockwork. Workers and machines carefully attach the display panel to the frame, install circuit boards, connect power supplies, and add speakers and ports. The casing is sealed, and the software is uploaded. At this stage, the TV finally takes shape, but the process is far from finished. Quality testing is the next critical step. Screens are examined for color accuracy, resolution, sharpness, and brightness. Speakers are tested to ensure clear, powerful sound. Ports are plugged and unplugged repeatedly to check durability. Even simple actions like turning the TV on and off are tested thousands of times to guarantee reliability. If a unit fails, it's either repaired or removed from the batch. Once a television passes all tests, it moves on to packaging. Special foam, plastic covers, and reinforced boxes protect it from damage during shipping. The packaged TVs are then labeled, stored in warehouses, and distributed to retailers worldwide. When they arrive in stores, they are carefully unboxed and displayed, ready to catch the attention of customers. Today, the global television market is dominated by brands pushing technology to new heights. Samsung, for example, is renowned for its QLED and OLED TVs, offering incredible brightness, vivid colors, and superb contrast. These are often the go-to choice for movie lovers and gamers alike. LG, on the other hand, has become a leader in OLED technology, delivering perfect blacks and stunning picture quality. Their models are popular with cinephiles due to advanced features like Dolby Vision and ultra-fast response times. From high-end innovations to budget-friendly options, these brands ensure televisions remain an essential part of daily life. From the early experiments of pioneers to the breathtaking smart TVs of today, the story of television is nothing short of extraordinary. The next time you sit down to watch your favorite show, remember behind that sleek screen lies decades of innovation and a complex process involving countless hands and minds, all working together to bring moving pictures to life in your living room. Every single second, Apple sells more than 30 AirPods. That's over 150 million units every year, making them not only the world's best-selling true wireless earphones, but also one of Apple's most iconic and successful products of all time. But what exactly makes AirPods so revolutionary, and how did Apple turn them from a ridiculed idea into a cultural phenomenon? When Apple first unveiled the AirPods in 2016, the world was skeptical. People mocked the design, calling them overpriced and easy to lose. Yet, within just a few years, AirPods completely transformed the way people listen to music, watch content, and take calls. They became a global symbol of convenience and modern tech. In 2019, Apple launched the AirPods 2 with enhanced connectivity and support for the voice command, "Hey Siri." That same year, AirPods Pro changed the game again, introducing active noise cancellation and transparency mode, elevating the listening experience to professional levels. Then came AirPods 3 in 2021, bringing spatial audio for immersive 360-degree sound, followed by AirPods Pro 2 in 2022, powered by the advanced H2 chip, offering industry-leading noise cancellation and richer sound detail. And for those who wanted more, Apple introduced the AirPods Max in 2020, premium over-ear headphones with unmatched build quality and sound depth. So how does Apple craft such sophisticated audio devices? The secret lies in their precision manufacturing. Each AirPods shell is made from high-quality polycarbonate plastic, molded at extreme temperatures around 250 degrees Celsius, then rapidly cooled for durability. The casing is laser-cut with an accuracy of just 0.02 millimeters, ensuring a flawless fit for the intricate internal components. Inside, each AirPod houses an 11 dynamic driver rigorously tested with automatic frequency systems to guarantee zero distortion. At the heart of every pair lies the Apple H1 or H2 chip, responsible for lightning-fast connections, ultra-low latency, and seamless integration with Apple's ecosystem. But that's not all. AirPods come equipped with optical sensors and accelerometers that can instantly detect when they're in your ears, automatically pausing and resuming playback. Each earbud also contains 2 to 3 ultra-tiny MEMS microphones, just 1 millimeter thick, capable of precise sound capture for crystal-clear calls and advanced noise cancellation. Even the batteries, compact lithium-ion cells around 93 milliwatt-hours, are soldered into place with laser technology to avoid damaging the delicate components inside. The charging case integrates wireless charging coils and a smart battery management chip to optimize power efficiency. Before leaving the factory, every single unit undergoes exhaustive testing for sound quality, durability, temperature resistance, and even humidity exposure, all within a 48-hour production cycle in massive factories across China and Vietnam. It's a process so refined that millions of units are produced each month with unmatched consistency. We need to look at the machines they power, like laptops. Have you ever wondered how a laptop, the portable computer you use every day, is built from start to finish? The history of laptops dates back to the 1980s. In 1981, the Osborne 1 became the world's first commercially available portable computer, though by today's standards it was bulky and limited. Soon after, companies like Compaq and IBM improved the design, making devices lighter and more efficient. By the 1990s, advancements such as lithium-ion batteries and LCD screens revolutionized laptops, making them thinner, lighter, and far more practical. Iconic designs like IBM's ThinkPad became legendary during this era. Fast forward to the 2000s, and laptops underwent a dramatic transformation. Sleek models like Apple's MacBook Air redefined portability, while powerful machines like Alienware catered to gamers demanding high performance. Today, laptops are more than just tools for work, they're essential for entertainment, education, and innovation. But how are these machines actually built? It all starts with the motherboard, the central nervous system of the computer. The process begins with a printed circuit board, where a stencil layout is placed and solder paste is carefully applied. This paste serves as the foundation for connecting hundreds of electronic components. Automated cameras scan the board for accuracy before robotic arms spring into action. Within just 30 seconds, as many as 150 tiny components are placed precisely onto the board. The assembly then passes through a reflow oven, where the solder melts and solidifies, locking everything into place. Another inspection ensures no errors remain. Next comes the laptop's display. Technicians attach protective films to the LCD screen and carefully connect delicate cables to the motherboard. The screen is then framed with a bezel, which includes the webcam and microphone, combining durability with design. Once completed, the display is ready to be joined with the rest of the system. The lower half of the laptop houses critical components: the speakers, touchpad, keyboard, and of course the motherboard. Cooling systems, including fans and heat sinks, are added to prevent overheating, especially in gaming laptops. Memory modules, Wi-Fi and Bluetooth chips, SSD storage, and a powerful battery are installed one by one. Finally, the keyboard is fitted, with laser etching adding precise lettering to each key. Before reaching consumers, laptops undergo intense quality control. Automated tests check the display, cooling system, and overall functionality, while technicians manually test features like color accuracy and keyboard durability. Only after passing these tests do laptops move to the final stage, packaging. Each unit is cleaned, boxed with accessories like chargers, and prepared for worldwide shipping. Many factories now also integrate sustainable practices, such as using solar power to reduce carbon emissions during production, ensuring technology advances hand in hand with environmental responsibility. And just like that, from a bare circuit board to a sleek and powerful machine, the laptop is born. It's a process of precision, innovation, and relentless testing, all to ensure the device in your hands performs flawlessly. So, which laptop brand are you using right now, and how well does it serve you? Share your thoughts, and stay tuned for more fascinating insights into the technology that shapes our world.